Okay, so we're given this question over here. A new foam target on wheels for archery student has been invented. The arrows of mass m and speed v naught goes through the target and merges at the other end with reduced speed v naught over 2. The mass of the target is 7m, okay, and ignore friction and air resistance, okay? So let's first state what is the final speed of the target. Okay, but before that, we have our question that arises. My apologies. Let's use black here. Let's have our knowns. Okay, our knowns in this equations is very simple. First, we know that the question says that the arrow, okay, arrow speed reduces to v naught over 2. Okay. The second is the mass of the target. Target equals to 7m. Okay. And we know to ignore friction and air resistance, which is a given, which is good. Okay, now we're gonna ready to solve. This is just a simple momentum question. So this is a simple conservation of momentum question. Okay. So this conservation of momentum question is quite easy. So first off, we always state our question. I guess our statement of conservation of momentum, which states the sum of all momentum in the initial equals the sum of all momentum in the final. So we know that v1 m1 v1 plus m2 v2 for the initial size equal to m1 v1 plus m2 v2 for the final side. With that given, couple things that we can assume. Okay, I'm just going to scroll over here. So a couple things we're going to assume. Number one, the assume that the cart, okay, or your target has a velocity of 0 meters. That's because it doesn't move. Meters per second, apologies, because that's because it doesn't move. Okay, and we're gonna list our m1s equal to the arrow, m2 equal to your cart in this case. Okay, so we're ready to go back here. After our assumption, m1, since we know that the velocity of the cart is 0 initially, we know that this is 0. Okay, and then we can continue on going from there. So mv naught plus 0 equals to mass v naught over 2 plus 7m v2 final. Okay, once again, that's because this side is your final side, this side is your initial side, remember, and that is good. Okay, then we have a common m that we don't know. Okay, then we're left with v naught minus v naught over 2 equals to 7v2f. Okay, then equals to v naught over 14. Thus being the answer. Okay, so that's your 1a over here. Now let's go to 1b. So it asks, what is the kinetic energy of the arrow after it leaves the target? The kinetic energy, okay, it is given by B. Let's go with B. Kinetic energy. The formula for kinetic energy is 1/2 mv squared, if I'm mistaken, okay? And since we know the velocity of the arrow, okay, is going to be v v naught over 2, we can make this equal to 1 half m v naught over 2 squared. That simply becomes 1 more t v naught over 4, which then v naught squared over 8m. Okay. So that's your second one right here. Okay. Let's do our number C question. What is the final kinetic energy of the target? Okay. So we're looking for C now. Final target kinetic energy. So that's very simple as well. Same idea. We got to use the same equation. 1 half mv squared. Okay. Where we know this is 7m, right, given from the equation, and this we had to find it, so v naught over 14, let me just double check, right, v naught over 14, yes, and that here is squared. Okay, and then we are good. So 1 over 2, 7m v naught over 14 squared equals to 1 over 2, 7m. 14 times 14 is 196 over v naught squared equals to 7 over 2. Multiply that by 196 v naught squared, which then equals to 1 over 56 v naught squared. Let me just double check. 7 over 2 times 196 is 156. Good. So that's your third one here. Okay. And then let's go to part D. So it says, what percentage of the initial energy of the arrow was lost in the shooting? Okay. So we're looking for the percentage loss. So percentage loss is actually pretty easy as well. Okay. So first off, we always need to look for the initial kinetic energy, okay, and then the final kinetic energy. It's a little more difficult for this question, actually. So let's look for your initial kinetic, okay? Okay, yeah. I think I'll try to make this as easy as possible for you to understand, okay? So that's 1 over 2 mv squared. And then the final, okay, kinetic energy equals to 1 over 8, right? mv squared plus 1 over 56 mv squared. Okay? How do we get those numbers, right? So 1 over 8 was for this one, right? Remember? Good. And 1 over 50 is that. Now, when we were looking at B, it looks at what is the kinetic energy of the arrow after it leaves the target. Where I was looking here, right? Kinetic energy after the arrow leaves the target. So that means our final kinetic energy, okay, the final kinetic energy will be the arrow speed plus the cart speed. Okay, so once again, the final kinetic energy will be the arrow speed plus the cart speed over here. Hence, that's why we have this equation over here, okay? Final kinetic energy, okay? Final kinetic equals 1/8, which is your arrow, and this being your cart. You add them up together, okay? And then we're good to go. So we then add them up together. Since 8 times 7 is 56, right? So we know that this is going to be 7 over 56. 7 over 56 plus 1, which is 8, right? Let's just simplify that quicker. mv naught squared, okay? Which then this equals to 1 over 7 mv naught squared. Okay, that's the energy lost. From there, we can go from the change in energy. Okay, change in kinetic energy equals to the kinetic energy of the initial minus kinetic energy of the final. Okay, which then is 1 over 2 mv naught squared minus 1 over 7 mv naught squared. Okay, which then equals to 5 over 14, mv naught squared. Okay, then the percentage will be this divided by Ki, which is your kinetic energy, times 100, okay? So why do I do that? Is because your delta Ke, okay, your change in over the beginner, sorry. That's the same as our like theoretical, right? Subtracted by actual, which is your loss, and then divided by your theoretical. Times 100%, that's going to be your percentage, correct? So in this case, this is the same. This is your the Ke here in this sense. This Kei is going to be your theoretical. This is going to be your actual value. So this is going to be our difference. So our difference, 5 over 14, sorry, let me do that again, 5 over 14 mv naught squared divided by the 1 over 2 mv naught squared, right, times that by 100%. Since we have a lot that can cancel out here, so cancel, right? So we're just left with 5 over 14, so multiply that by 2, 2, 1, 7. So that means that's going to be 10 over 14 times 100%, which that means it's 71.3%, which then we can round it up to 71%, being the percentage loss. I hope this helps, and I'll see you in the next video.